Hi, everyone. My name is Jay Faulkner. I'm an open source developer with G Research Open Source Software. I'm host of the Gross Outreach podcast, where we talk about real stories from open source and don't leave out the gross bits. And I've been working on OpenStack with a focus on Ironic for a little over 10 years. And in fact, that anniversary is sort of what drove me to want to give this presentation. Ironic was first a part of an OpenStack release back in Icehouse in 2014. So it's been about 10 years since we've released Ironic, and I wanted to go through a comprehensive list of all the things that Ironic can do. Now, this is a very shallow um, look into Ironic. We're not going to talk in detail about how to do any of these things, but what I'm hoping to do is to give you an overview of what all's there, what's on the menu, so to speak, that you can pick up and use Ironic to do. And then later on, you can go look at the Ironic documentation, go ask an IRC, or maybe even get in the comments here on YouTube, and we can go into a little bit more in depth into how to use these. But the first thing I wanted to mention is that, Ironic is 10 years old. We release at least once every 6 months. So you're talking about over 20 different Ironic releases that you could be running. So when I'm talking about a specific feature in Ironic during this talk, I'm going to call out the year that it first appeared in Ironic. Now, always using the newest version of Ironic you can is the best path to succeed because you're going to get all the best bug fixes, the best hardware support, all of that. But, I know it's not a perfect world. You may not be able to run Caracal, but, perhaps some of these features will be available to you anyway. The other thing to keep in mind is that not all Ironic features can be used in all contexts. So what I mean by that is, if you're looking at Ironic through a specific, more generic API like Metal Cubed, which exposes a portion of Ironic's functionality through a CNCF style API, or if you're using it via Nova, then you're sort of getting a limited set of Ironic's features when it comes to deploying those instances. And so for purposes of this talk, I'm going to assume you've got direct access to an Ironic API server to do things with, which that's always possible, even if you're using these things in front, but just pointing it out. And when we start getting into deployment related features, I'll take the time and point out, how you can use these with Nova specifically. But first, I wanted to start us out with a basic architecture of Ironic. I just don't want to throw a bunch of terms at you without you understanding what they mean first. So let's talk about the basic design of Ironic. You start out with, some sort of API user, a person making curl commands, an API client with OpenStack SDK. Maybe you're using Python Ironic client, CLI, or maybe you're using Nova or Metal Cubed. Either way, all of those things are going to hit a public HTTP REST API endpoint at the Ironic API. The Ironic API server itself, that service, handles really basic things, but for most API calls that do a significant amount of work, it's going to route that request back over RPC to one of our Ironic conductors. And conductors are what do a lot of the actual work to provision servers. Now, you don't necessarily have to have every node configurable by every conductor. We support splitting up conductors in groups and assigning them to nodes. And also, conductors are kind of self-selected by drivers. So if you have a node that's using a specific driver and only some of your conductors use that driver, Ironic will figure that out and make sure that a capable conductor is the one you use. And also, if you're using a really low-scale Ironic deployment, you can run these in a single process, although that's not an architecture you see very often. As a developer, I think about them as two services, and I'm going to be referring to them as two services during this talk. So there are several ways that conductors can control servers under Ironic management. We generally call these nodes, by the way. A node is an Ironic representation of a server or really any device with a BMC that Ironic might try to control. So the Ironic conductor basically has two ways that it does things on it. I've already referenced one, which is the BMC, the node's management interface. You might hear us call this out of band. We also refer to these sometimes by the standard or technology they use. So if we're talking about Redfish or IPMI or an ILO or a DRAC, these are all examples of a node's out-of-band management interface, or BMC. And different hardware and different hardware BMCs support different actions. And in fact, Ironic can even be used with servers that don't have an out-of-band management interface, but instead can do power control via a PDU or something similar. The more universal thing is in-band. And this is Ironic booting a RAM disk on the node that contains the Ironic Python agent inside. That Ironic Python agent can perform basically any action that you could perform in Linux or Python via the agent itself. It's also really customizable, and we'll get into that in a little bit more detail later. But sort of talking about hardware, I do want to mention that we do definitely have preferred hardware for Ironic these days. Redfish is the open standard published by the DMTF for BMCs. It's an HTTP API. It's a vast improvement over the previous technologies or the vendor-specific ways of doing things. So you're going to want to use Redfish hardware if at all possible. Now, we have other drivers for a reason. We support lots of different things, but if you're buying hardware and Ironic's going to be managing it, buy Redfish. But how would you tell Ironic what hardware you have and how to use it? Well, that's what hardware types and drivers are for. Hardware types are the way that Ironic adapts to different server configuration. And it's just a collection of interfaces for a specific piece of hardware. These interfaces are pluggable implementations of Ironic functionality that are often dependent on hardware capabilities. So what does this mean? Let's go into this a little bit of detail. So I've listed off in the next couple of slides all of the interfaces in Ironic with a few examples of implementations of them. And it'll serve as an example to kind of show you the role that an interface plays in telling Ironic how your node is controlled. So, we have a BIOS interface that can create, read, update your BIOS settings. And, Redfish is one of our best implementations of that. But we have the boot interface. The boot interface is one of those that you might want to change because your hardware can do more. By default, we use the iPXE driver, which means that we PXE boot, which is a standard way of booting an operating system on a computer over the network. And we use that PXE boot to do whatever we need to do with it, usually booting a RAM disk agent to get things started. But there are other ways to get that RAM disk booted on a node. For instance, if you've got a fully featured piece of Redfish hardware, you can change over and use the Redfish virtual media boot interface, which provides you with a way to sort of virtually insert a CD-ROM into the drive or a USB key so that you can then boot up something without having to do the dance of a network boot. We have console. We're going to talk a lot about deploy interface. Deploy interface is the easiest thing to change regardless of your hardware if you have weird needs for how you deploy servers, and I'll talk about that in a lot of detail later. Got the firmware interface. We've got inspection interface, and this is another example of how interfaces are not always about different hardware capabilities. It can be about changing the way that Ironic does something. So in this case, we have the agent inspection driver, which boots up that RAM disk agent in band and uses kind of Linux tooling to inspect the hardware. The inspector interface uses our legacy Ironic inspector service to do the inspection and handle that. And Redfish uses the out-of-band controller. It queries the Redfish and says, tell me about the hardware. These are three distinct methods of inspecting a server, and you can change that in Ironic just by changing the inspection interface and maybe a little bit of required configuration depending on what you're changing it to. The rest of the interfaces, we have management. That's what we use to tell the machine what boot device to boot next. So we can control PXE booting versus local disk booting. It's optional, but it's a nice thing to have. Network interface, which allows you to plug in different ways of managing networks. Today, the only meaningful implementation we have of this is Neutron, but we have a project underway to provide a simpler interface for people who want to use Ironic standalone. We have power interface, which is server power control. This is just turning machines on and off and rebooting them. And we have lots of different ways of doing that. RAID for configuring RAIDs. We've got rescue interface for rescuing servers. And think of this like a rescue CD or a rescue USB. Just like if your computer at home didn't boot, you would put a USB key in it or something, boot up into a live environment and try to fix it. That's what rescue does, is it gives you an opportunity to tell Ironic to give you a rescue environment to go fix a node. We have storage interface where Ironic will coordinate attaching and detaching storage during power actions and things like that for you. So with these interfaces, a given hardware type can support multiple options for the same interface. And when you override the default interface for a type, you can do that in configuration or per node. So you don't necessarily have to have the same interface for every node in your cluster. But like I alluded to before, if you're picking an interface, you need to be certain that your hardware is going to support that. And you can try it on one node just to make sure, or that you've got any configuration that we documents required in place for that. So here's a little bit of a graph as an example. I picked the Redfish hardware type, and the Redfish hardware type defines multiple boot interfaces and RAID interfaces. And it's a lot more than the two listed here. I've just picked these two to make it a little bit easier to reason about. So for instance, with Redfish, even though the iPixie is the default boot interface, it lists others like, Pixie, HTTP iPixie, Redfish Virtual Media, and you can change from that default to the Redfish Virtual Media boot interface because the Redfish hardware type lists it as a supported one. To put this in perspective, you couldn't pick things like a Redfish Virtual Media boot interface if you're using an IPMI driver because you can't talk Redfish to an IPMI server. That's sort of an example of what hardware types are protecting you against. And again, for RAID, you can choose Redfish or an agent. And in this case, agent doesn't even really depend on special hardware. It's just using software RAID configured in band. So just a couple of examples to show you how you can adjust interfaces to adjust what actually happens on a node in Ironic. So we've sort of talked a lot about Ironic's structure, some of the terms involved. And so now we're going to get into sort of the bread and butter of what Ironic does here with the server lifecycle. And I think that these features are the sort of things that most people are thinking about when they think about Ironic and what Ironic and its competitors can do. So the first thing is node onboarding. This is when the truck backs up to your data center and has racks of servers. What do you do? Well, first thing after you get them racked and stacked is you're going to enroll them by adding basic node information to Ironic. Generally speaking, the minimum amount of information you would need is the hardware type. Information for BMC access. So if you're using Redfish, that would be like a Redfish username, a Redfish password, and a Redfish address. But just whatever you need for the driver you're picking, for the configuration you're picking to get that node enrolled. Once it's enrolled, it's going to go into our enroll state, which is just kind of sitting there waiting for further instruction. When you're ready for those, you put them into manageable state, and then it passes through a validation. And the original version of validate was just making sure that some keys existed. So like for instance, with Redfish, it would make sure that you had a Redfish address set or a Redfish username or a Redfish password set, but it's not going to make sure that all of those are necessarily sensible. But in 2021, we added verify steps, which allows some of our out-of-band drivers to do a little bit of work before the node is ready, while the node's enrolling, or to do some testing to make sure those credentials actually work rather than just the fact that they exist. And then, so you've got it enrolled, you've got it validated, then you have a node in manageable state. You can either put it, send the verb provide to put it into available, make it ready, or you can inspect it. And this is what most people will do at this point, is they're going to inspect. And inspection, it uses the interface dictated method to get information about the server. We already talked about that a little bit. And that information can be saved either to a database or to a completely separate data store. And this is really trivial to customize. So if there's something you need to inspect on a machine that you don't think Ironic supports today, let's talk and we can help you out in getting it working for your environment downstream. Or maybe even if it's something that other people might want to inspect, we can implement that upstream for you. So we then get into kind of the life cycle of the node, right? We have that node. We put it into available state. It's sitting there in the inventory. And that's just kind of where it's going to park until it's deployed. Now, for a lot of people, when I say deployed, you may think of like this as being an OpenStack server create command if you're used to using Ironic through Nova. But this doesn't actually create the server. Obviously, it's a physical server in the real world. So we just are provisioning an existing node in Ironic. Once that provisioning is complete, the node's deployed to, and we'll talk about how that happens a little bit later. Then it ends up in active state, and it's running an instance or a workload. This means that someone actually has something on this machine doing what it's supposed to do, crunching numbers, mining Bitcoin, whatever you're doing with your hardware, when it's in active state, it's doing it. And so when someone's finally done with that, let's say they're scaling their cluster back down or something of that nature, they're going to send an undeploy command to Ironic. And again, if you're using Nova, you might be more familiar with this as a OpenStack server delete, but we don't necessarily love using that word delete here in Ironic because delete is what you do when the server comes out of the rack. But this is just undeploying it and getting it ready for the next person. So once that undeploy starts, what Ironic does is it passes it through a process we call cleaning. We'll talk about cleaning a little bit more in detail later, but essentially it's just Ironic's way of making sure that no data or information from the previous workload ends up on the next person's server for them to inspect, because that's obviously not ideal. It would be a big security issue. But what if you're ready for a server to be retired? You're actually ready to get it deleted from Ironic and not just undeployed. Well, we give you a flag here to allow you to sort of drain nodes out of your environment. And this is node retirement. And if you set a node as retired in Ironic's API, you're going to allow them to be removed as that node gets undeployed rather than having to be disruptive to your customers. And so you end up changing the workflow here a little bit, where now if you're at the bottom, the node's running a workload, is active state, you're going to call the API and you're going to set that node as retired. With that node being set as retired, when it goes through cleaning next time, what's going to happen is instead of going back into available state, where it's going to be in that sort of pool of available inventory for us to do something with, instead, we're going to leave that in manageable state, which is that same parking place we put it after we enrolled it, so that it's sitting there. You can then do anything you can do to a node in manageable state, which can include manual cleaning, which, spoiler alert, we'll talk about that a little later. Or obviously, if you're just done with it, you can delete it from manageable state. But as long as that node is marked as retired, even if you try to force Ironic to deploy to it, it will refuse. But it's not immutable. You can set a node as unretired. So we're going to keep going. We're going to talk about steps. Steps are the term in Ironic we use to describe a unit of work. When we deploy, when we clean, all these are just orchestrations of these steps that lead to an outcome. And if the whole premise theme of this talk is that, Ironic's a toolbox, these are the primary tools. These are your screwdrivers, your wrenches, the things that you're going to use every single day are generally going to be steps. A step in terms of like an object is a name, an interface, a priority, in which 0 means disabled, and we'll talk about where priority matters, and then arguments. Some steps are only usable in some workflows. So for instance, if it's an automated workflow and you require an argument for a step, you're not going to be able to use it. So what are the types of steps we've got here? We have in-band steps, and we already talked about what in-band means. It means we're actually booting that Ironic Python agent RAM disk onto the server, and we're going to use Linux commands and Python to perform tasks for us. In-band is extremely easy to customize, add your own steps, even adding local stuff. So if you have a special device from a vendor, you can embed their utilities in your RAM disk and write a little bit of custom wrapper code around it so that you can use those utilities in cleaning instead of the generic tools. It can be very useful in that case. The next type of step is an out-of-band step. Now, this is going to perform kind of interactions with the BMC to do step. And in this case, it can come from a lot of different interfaces. Like we've already talked about, there's Redfish, there's IPMI, there's ILOs, there's all these different types of out-of-band interfaces, and all of them can support kind of different things here for steps. So in some cases, we've got them made generic, like with the BIOS interface, the RAID interface, but oftentimes these steps may be hardware specific, and they're really not designed for significant customization. They're coupled pretty tightly to the interfaces. And the final type of step is a new type of step. I kind of call them control flow, although admittedly it's just a made up grouping for the most part. Control flow steps can do things like power on and off a node or its child node. You can wait for a specified period of time in seconds. You can even hold cleaning or whatever sort of process you're going through until the API is called to unhold that cleaning. So it's nice for allowing integration of external systems where maybe you want something to stay in cleaning until some external system has attested that it's clean or something. We support that. So there are some steps built in. The first one here in the list is erase devices for agent in-band. This is the one that we enable by default. And what this does is it does a full disk erase. If it's possible to use the ATA secure erase commands to do this, meaning like an API call to NVMe or such to say wipe your disk, that often can happen instantaneously if you've got enterprise drives. It's really neat. But if we're not able to call those APIs, then we're going to use the program shred to wipe out the disks, which is going to write zeros across the entire disk and can take a long time. For this reason, we introduced a couple of other options that you can optionally enable and disable erase devices if you'd like. Erase devices metadata, instead of trying to erase the entire disk, is just going to erase things like file system metadata, RAID superblocks, that sort of thing, just to make sure that there's nothing that could interfere with the next deployment, even if it's not securely getting rid of the data on disk for you. And then we have a hybrid option, which is Erase Devices Express. This is pretty neat because if you've got one of those fancy disks, which can take the API call to instantly secure erase themselves, we utilize that. However, if we can't instant secure erase using that API call, instead of doing a full shred across the disk, which if you've got large and slow disk can take a day or longer, instead of that, you can just choose to do a metadata erase on machines that don't instant secure erase. So if you want your cleaning to go fast, but opportunistically be secure, enable Erase Devices Express instead of erase devices. And there are obviously other steps. We have an entire page in our docs that list off all of them. We've got update firmware out of the firmware interface, which will update your firmwares. We've got apply configuration out of the BIOS interface, which will apply a given BIOS configuration to a node. We have various burn-in steps for burning in disk, CPU, memory, network, and it'll perform a burn-in test on that indicated component as part of cleaning. We can also create configuration via the RAID interface. And like we talked about, RAID's an interesting one that we have both out-of-band and in-band implementations of. So custom steps in IPA. How do you do that customization? Well, I'm going to talk about it from a really high level just because I want you to understand that it's not really that painful, especially if you're already building your own RAM disk images. First, you're going to go into the Ironic Python agent repository on opendev.org/openstack/ironic-python-agent. If you look in there, there's an examples folder. That folder contains 3 different examples of plugin hardware managers you might want to write for Ironic Python agent. Pick the one that most closely matches your use case and go ahead and copy out that entire directory into its own repository. It's already built in there. It's got all the skeleton things you need for it to be a Python package right there inside the example directory. Those examples have some pseudocode written and have very detailed comments as to how to implement this hardware manager for what you need to do. So literally the documentation is right there in line. Just go open up the files, read through them, and implement it as it's suggested. If there's any problems, any questions, any things you don't understand after going through that process, we also have extensive documentation in the Ironic Python agent docs about hardware manager and how that interface works. But once you've got that created, you've got it written up, and you don't have to be fancy. It's Python, but no one's going to judge you if you just sub-process out to something and check the exit code when it comes back. That's perfectly fine. Just whatever's easy, whatever works in your environment. Now, you just have to embed this hardware manager into your RAM disk. And all you have to do to make this happen is to do a pip install of that newly created Python package inside of the same virtual environment that Ironic Python agent is installed in. So you just put them side by side, and Ironic Python agent will pick up the new hardware manager that's added. And then using, configuration or API calls to update the node, you can tell Ironic to use your new RAM disk. So now that we've talked about what steps are at our disposal, let's talk about where and how we can use these steps in step-based workflows. The first and sort of the original one here is automated cleaning. And this is that cleaning that occurs when a node is undeployed, when you do the OpenStack server delete, it passes it through cleaning. By default, like I said, it only contains that erase devices step in band to erase the disk, but it's really easy. You can add a custom hardware manager like we just talked about if you need to add your own steps, or if you want to add some steps to automated cleaning that are disabled by default, you can adjust conductor clean step priority override to increase the priority of disabled steps or to decrease the priority of steps that you don't want to run. And only steps with no required arguments can be used. But I'm going to take time here to note something. It used to be pretty common for people to want to disable automated cleaning in their deployments because it tended to cause issues or things like that. Most issues that you see during automated cleaning are issues that you would see at deployment time anyway. So it can be a good canary for detecting those sort of issues when things come up. But even beyond that, some of the most common bugs that we see as upstream Ironic developers are from people who have cleaning disabled and are having issues with their deployment process based on data that's still sitting on the disk, like a leftover partition table, a leftover config drive, things like that. So for your own sanity, leave automated cleaning enabled. If you really are pressed for time, switch it up so that you're only running erase devices metadata. But if you completely disable automated cleaning, you might have issues. And quite frankly, as upstream developers, there's not a lot we can do about it because wiping out those disks is the ultimate defense against that kind of bug. But there are non-automated ways that we can do this too, such as node servicing and manual cleaning. This is a lot more explicit. We just pass a list of steps to execute on a node in an API call. Manual cleaning is designed for undeployed nodes. So if you've got any nodes in that kind of parking area of the manageable state, you can take them from manageable through a set of cleaning steps you specify and back into manageable. This can be useful for all sorts of ad hoc maintenance or testing. But more recently in 2024, and actually in our last release, we just added node servicing. And this is designed to allow you to take nodes that are deployed that have an instance or a workload already running on it and perform maintenance to it. And so in this case, you would have that node that's inactive, it's already there, someone's using it, you can perform service on it, and then it goes back to active. Now, it may reboot your server. If you're giving it a step that's going to cause the server to reboot, it's going to reboot. But this is still a way to do some of that basic maintenance through Ironic and our automation. Another way, and in fact, a really common way that people are using steps is to deploy with steps. And the explicit way to do this is when you're deploying a node, you just specify additional steps to run. Now, there are some steps in Ironic that are implied, that are built in, that we're always going to include on our default deployment interfaces at some priorities that we document. And then, whatever steps you provide, we merge those steps together with the required steps for deployment to build up a whole process. But there's a big downside to this, and that's that if you're using Metal Cubed, if you're using Nova, you don't have access to this feature because you cannot specify arbitrary steps at deploy time for any non-standalone Ironic deployment method. But that's okay because that's why we added deploy templates in 2019. Deploy templates are a pre-curated list of additional steps to run during deployments. These, just the same as when you specify the steps explicitly, they get merged in with those deploy steps that Ironic includes every time. And what you can do is you can set up a flavor in Nova to map to a trait that matches that deploy template's name, and that deploy template will be used at the deploy time, and that allows you to do some really cool just-in-time stuff with deploy templates, like, for instance, having a set of deploy steps which would enable or disable hyperthreading and wiring that through to two different Nova flavors. So if someone picked one flavor, they would get a node provisioned with hyperthreading on. They picked the other flavor, they would get it provisioned with hyperthreading off, but it's still operating over the same pool of hardware. You're just reconfiguring it on the fly. Lots of really cool creative things you can do with this. But let's go more in depth about deployments and how deployments work. Up until this point, I've been sort of taking for granted that you're using our default deploy interface a little bit when I talk about things like deploy steps and all that. But we have lots of them, and a lot of them support niche use cases. So if you're a person who this meets your use case, then congratulations. We might support something you didn't know about. But first, we'll talk about the default, which is deploying images to servers. We call this our direct deploy interface. It used to be called the agent deploy interface because it does exactly what that sounds like. It boots up a RAM disk running Ironic Python agent. We communicate with that agent over an API to tell it to write an image to the disks. And this is what's default. It's what's used by most Ironic operators. If you hear someone upstream talking about how a server's deployed, you read docs about how a server's deployed, they're almost certainly going to be describing the process for the direct deploy interface. Now, this has a lot of good strengths. We already talked a lot about how to customize this with those in-band steps and using deploy steps or deploy templates to do that. And really, if you're already using OpenStack or any cloud in general, you're familiar with image deploys. It's the concept that exists a lot in the cloud. But that's actually kind of a weakness of this too, is that you have to provide a working image. And unlike a virtual machine where you might be able to go download a cloud image and just use it out of the box, many distributions will remove physical hardware support from those cloud images. So you might have to work to get yourself an image that works properly. And there's no support for on-the-fly custom partitioning here. If you want to have special partitioning, you need to have those partitions baked into a partition table in the image you create. In fact, a lot of Ironic deployers will just add most of the disks in those images to an LVM pool so they can expand it as they need once it's deployed. But what are the other options? We can deploy a RAM disk to your node. So this is a little bit tricky. You can't confuse this with Ironic using a RAM disk to put an image on a disk. This is if you actually just want to boot a RAM disk and that's all you want to do. You don't want an image put on your disk. You don't want anything else to happen but Ironic to take a RAM disk that you provide, usually in ISO form, but just a kernel and a RAM disk work, and get that booted on the node for you. This allows pretty much drop-in replacement of ISO-based workflows where you might have provided an ISO, it gets booted. Doesn't really even require working local storage. But again, you have to make an ISO image that works, which is less trivial than you would think. And there are limitations around config drive here. Because we're not really writing an image to a disk, we can't really write a config drive to the disk. It limits the things that we're able to do in terms of configuration on the fly. The next deploy interface is deployment via Anaconda. You might already be familiar with Anaconda. It's the name of the installer used by RHEL and RHEL-based operating systems. And so if you've heard of Anaconda, you almost certainly know that a kickstart file can be extremely powerful. Kickstart files allow you to automate installations of Red Hat or Red Hat-like operating systems. And it's a very mature installation tool. You can do custom partitioning on the fly. You can install and configure images and things like that. And this is really its strength, is that you get all access to all the things that Kickstart's done. Kickstart's been around for decades. It's a super useful thing. And it also unlocks custom partitioning. This is the only way in Ironic today to get custom partitioning on the fly when you deploy. But it has a couple of weaknesses. It's only been tested on RHEL 8 or 9, or realistically probably CentOS Stream 8 and 9. And only can support, by its nature, a RHEL-like operating system. The other one I'm going to note here, and it's not on the slide, but if you're deploying with Nova, then you can't provide a kickstart file on the fly. You have to kind of map it back with flavors like we talked about before with deploy templates, where you still have to pre-curate those kickstart files though. So if you're using it with Nova, you lose a little bit of utility there. We're currently working and thinking about designs as to how to improve that. If you have ideas, please let us know. And the final one is deployment via homegrown tooling. I've kind of mushed a couple of different options together here. I'm going to warn you that you probably don't want to do this. If you're at a level in Ironic that you're watching this video, these are not things that you likely want, but they're here, and I want you to understand what they're for. Ansible uses custom Ansible playbooks to deploy. We just boot up that RAM disk with Ironic Python agent, but instead of using that agent API to deploy the node, we're going to just SSH to it, execute some Ansible. And so you provide your Ansible playbooks. We do whatever the Ansible playbooks do, hands off. That's up to you. Nothing really works out of the box. Custom agent is similar with nothing working out of the box, but the description of it's even more basic. This is essentially our direct deploy interface with those required steps removed. So, with the direct deploy interface, you can specify deploy steps. They get added on to the steps that Ironic always runs to deploy. If you're using the custom agent driver, we take those steps away. We're not going to write an image. We're not going to make sure there's a config drive on disk. None of that. We're trusting that the steps that you provide are doing everything you need to provision. So again, you can customize this to your heart's content, but nothing at all works out of the box. And you probably don't want this unless you're using Ironic as a platform for some other product. So these are the deploy interfaces, but what does it look like to actually try to deploy a node with Ironic? Well, it's kind of complex. Can be error prone because first of all, you make some calls to update the node. You can put the instance UUID in there, put some metadata and instance info. You might have to make some calls to Neutron to set up your virtual interfaces if you're using that, or calls to Glance to prepare an image if you're doing that. Then eventually you're going to call the Ironic provision state API to deploy. This has several downsides. It's an error-prone multi-step process. It's not really a great user-friendly way to deploy servers. And also, you have to know what node you're deploying to do this. You can't just say, give me any node. You have to say, I want to deploy this specific node in Ironic. Well, that's when we added the allocations API, which solves some of these problems for us. You can ask for an allocation with resource class and or traits, and we'll go find you a resource. We'll find a node for that. We'll set up an allocation for it and set the UUID, the instance UUID on that node to the allocations UUID. And then that allocation will stay in place until you manually delete it or until that node is undeployed later. So it sort of gives you a little bit of a scheduling mechanism for Ironic and a way to sort of atomically claim a node. But really, this is only used by one tool today, and that's Metalsmith. Metalsmith was created in 2019. It's a deployment and scheduling tool for Ironic and Neutron that you can optionally have it coordinate with Glance as well. And this essentially is a client-side effort to solve that deploying nodes directly in Ironic is complex problem, where instead of making multiple API calls across multiple CLI commands, you make one CLI command and it does all the work for you. This project is still supported. However, we're not really adding new features to it. We're currently thinking about and trying to design a better API interface so that the ease of deployment with Metalsmith can be brought to all API clients, because we shouldn't need a fancy client to make it easy to do this. We know that and we're working on it. Another tool that Ironic has, which will deploy nodes for you. It also will install Ironic for you. So it's kind of crossing lines here, is Bifrost. Bifrost, the standard use case for that is you have a couple of racks of servers and you want an operating system on them. You can put Bifrost on a VM in your laptop, plug it into the network, and deploy all those servers, and then just be done. You can just shut down the Ironic. You're done. You've deployed a bunch of servers. Congratulations. You can also leave it there to have a more longer running Ironic. But for me, I think the coolest feature of Bifrost is that it's based on Ansible. The Ansible playbooks are right there. You can take them, you can customize them for your local needs, or use them as an example if you too want to drive Ironic standalone via Ansible. This talk is not covering deploying with Metal Cubed. It uses cluster API stuff. It's got its own documentation. I don't really speak CNCF. There are a lot of good talks on Metal Cubed out there. I recommend you find one. Maybe I'll get one in the description of this video, so that if you're interested in that. But that's kind of out of scope, because even though Ironic is involved in deployments with Metal Cubed, it's very much a strict proxy thing back from Metal Cubed. You don't really get to see the Ironic API that much. So it looks a lot more like CNCF than it does OpenStack or API-based stuff. And so that's sort of out of scope here. So up until this point, we've talked about things that Ironic can do, how it deploys things to nodes, how it controls those nodes, steps it does. These are all kind of oriented to doing automated things on a server. But Ironic's entire job is to make the job of the operator a little bit easier. So we have some features that are specifically made to help scaling or operating Ironic itself a little bit easier. So I alluded before to conductor groups. This allows you to configure a set of conductors to be in a group together, and then you can set that conductor group onto nodes to force them to be sticky to that group of conductors. This can be very useful if you have a deployment where maybe you have a data center with different security zones, and your internal policies require you to always have, computers in security zone A be accessed by computers in security zone A. So you can have a conductor right alongside those machines and not have to have that BMC communication or that provisioning communication crossing over those computer rooms. We know of people using this feature for geographically distant servers. They might have an Ironic API in one area, and then it's making RPC calls across, to another state to provision nodes over there that maybe, you don't have a big enough environment to make it worth running a whole OpenStack. Nova is conductor group aware. There is an option you can set in Nova where you can tell it to only look for nodes in a certain conductor group. And in 2019, when this was released, that was really the only way you could horizontally scale Ironic nodes across Nova computes. But, kind of obviously, conductor groups have their own feature, right? Like that sort of locality between server and conductor that's managing it is an important feature that a lot of people need, regardless of scaling. So we went ahead and saw that, and we took the scaling mechanism and split it out into its own concept called node sharding. We added a value of node.shard to that node object, and you can set it to an arbitrary string. And when you have that shard set to an arbitrary string, you can then query on that. It's very well indexed. And so the idea here is that, let's say you have 10,000 nodes, you can put those in 5 different shards, set up 5 different Nova computes that are all pointing to each shard independently, and then each Nova compute is only managing a subset of those. Similarly, you can use that same idea for your own operational scripts. It doesn't have to be Nova. This is literally just a get filter of shard. So put it in your own operational scripts. And we also are going to use this as a tool in the future if necessary to help Ironic scale out. We've talked about, for instance, adding support to networking generic switch for sharding if we find that that's a need. We also have a graceful shutdown support for the conductor. In 2023, we added basic support for this, where just when you go to shut down a conductor, it's going to wait until it's done with anything it's immediately doing on the nodes that it can remove the lock. So if it's communicating with an agent, if it's updating a firmware on a BMC, something like that, it's going to complete that specific thing that it's going, and then it will stop. So this means if you're deploying, your deployment still might fail, your clean still might fail, but we're not going to stop in the middle of an action or do something that could be dangerous to your servers. If you want to do a completely non-disruptive move, you have to use SIG user 2. And when you send the signal SIG user 2 to a conductor in 2024 releases or later, that will wait a very long time for any deploys or cleans that are in progress to finish. And so we're not just talking about one step being done, we're talking about the whole process being done. The default timeout on this is several minutes, but it can be raised significantly higher if you want it to be higher. And this will also make it where that conductor won't accept new work. So, I think about this in load balancer terms. This is a drain fail, right? So you can send SIG user 2, wait for that conductor to get done with whatever it's doing, and then perform the maintenance you need on that server. We also have node history. Before we added node history, we just had a last error field on the node that you can consult to find out the reason it errored the previous time. But that didn't always work so well in cases where you might have had more than one error, or where you're maybe trying to track patterns of failure across the life of a node. And for that, we have node history, where you can query a historical look at the node in addition to its current status. It's useful for troubleshooting nodes, kind of finding failure patterns. That is configurable in settings how much of node history to keep. I think it defaults to keeping about 30 days of it, and the trade-off there is always just database size. And finally, this is, I think, the one of the best features of OpenStack in general, or Ironic, that's not used as much in its notifications. This allows you to configure Ironic and like I said, really any OpenStack project to send notifications to a message bus like Kafka or RabbitMQ or a log file anytime certain actions happen. And these notifications are sent on so many triggers, state changes, when an API resource is created or modified, or really any action Ironic can perform, we're going to send out a notification when that action is done. And you can look at those. You can collate the data, use it for billing, use it for troubleshooting, use it to gather statistics. I even had a manager at a previous job who used this to build up a dashboard of success rate by looking at Nova's notifications of attempted builds and reschedules and Ironic provisioning start and ends. So lots of really cool stuff here. I think this is a super underutilized feature, and I'd love to hear about your experience using this in the comments. We also have node adoption. And adoption allows you to add servers to Ironic that might have already had a workload installed on them. So you've already got it running on operating system. You don't want to have to force that server to go down to get reinstalled, but you still want it managed by Ironic. You can adopt it. This is only officially supported by standalone Ironic, but we do have a process in our documentation as to how you can adopt nodes into Nova as well, but it's not supported by Nova. Essentially, we just lie to it on the Ironic side and tell it we deployed a node and we didn't. So you can use this if you're using Nova, just we don't necessarily support it. You should go look at that document and see how comfortable you feel doing it, test out the process. But if it causes issues, that's not something that upstream OpenStack is going to be real keen to help you with because it's not supported. So finally, we've sort of talked about things that Ironic can do to servers via steps and sort of stepping through workflows. We talked about tools for operators, where an operator using Ironic has all these knobs, all these tools at their disposal to help them operate Ironic and understand what's going on. But as of late, Ironic's added features that are intended for the end user, for the person who's actually, logging into that instance that we deployed on the node. This is more closely in line with how other OpenStack projects have worked for a long time. In most other OpenStack projects, there's no concept whatsoever of having a primary object. Like there's no instance in Nova that is not scoped to a project. So in Ironic, we're trying to go the same route. We now allow nodes to be assigned to a project via two different fields. We have owner and we have lessee. Node owner is intended to model like a permanent node owner. So this would be, a project team at your work that maybe this server came out of their budget. Or maybe that node owner project is your operations team, that manages your nodes. And lessee is meant to be the temporary, like the instance user, the person who's logged in there. This might be, if your node owner is the platform operations team, maybe the node lessee is someone from your data team that's using that server. And the reason this is valuable is that OpenStack policy in general, and in Ironic as well, is completely customizable. So you can allow a lessee to do a limited set of things, maybe allow an owner to do more sets of things, and be able to start using project scoped things with proper like role-based access control, as has been pushed for in OpenStack for a long time. There's actually an extremely good talk that was at the Vancouver OpenStack Summit about how some of this works. I'll make sure that that's linked in the description below. So there's some cool things you can do with this. If you sort of think about it and start mixing the features together in your head, along with a little bit of extra fun stuff we added to make it easier. You can set a config on your conductor to permit a project scoped manager to create nodes in Ironic. And if you've given them that access, that can automatically set node.owner to that project as well. So you don't necessarily need to be a system level admin to onboard hardware. That's a great boon for security. We have support for automatically setting node.lessee when a project member deploys a node. We've supported that via Ironic directly in Ironic standalone mode since 2022. And we're working on that right now for Nova. We're hoping that'll get into the Dalmatian release, but that's still ongoing. Or, you can even have a single Ironic cluster servicing multiple projects, have, real node owner as multi-tenancy, and you can even have a Nova compute set up with a project scoped user that can only see nodes from that project. So you can really have Ironic be fully multi-tenant aware to create this cool bare metal as a service. So what's next for Ironic? This is sort of a question that comes up all the time. And there's a couple of things I mentioned in here, but the reality is that one of the hardest problems we face in open source is the feedback loop from users and operators. So if you're watching this right now and you have ideas as to what's next for Ironic, you've got some inspiration from something we talked about, please get in the comments below. Tell us what you think is next for Ironic. Or go into IRC, go to the mailing list, have a conversation with us about things that you wish Ironic could do today that you don't think it can do. And maybe it doesn't and we didn't document it well, or maybe you're the first person to think of this awesome idea and we'll get to be able to do it and credit you with the idea. So that kind of leads me to our best feature being community. Over the last 10 plus years of Ironic, just in the Ironic repo, and the Ironic project itself in whole is like a couple dozen repos, but just in the Ironic project, we've had 600 unique contributors. That's pretty amazing. Thank you if you're one of those people who's contributed. If you're one of the people who's used Ironic, who's helped us last for these 10 years, thank you so much. And, like I said before, we want you to be a part of the community. Tell us about the use case you don't think we handle. Ask us questions about how to implement a feature you heard about today. Or, if you just want someone to commiserate with you when your hardware is misbehaving. We've seen hardware fail in all sorts of crazy fun ways. And we'd love to hear your story of that on the ground. And so you can find us at pound OpenStack Ironic on OFTC IRC. You can also reach that via Matrix, or you can reach us on the OpenStack Discuss mailing list, which is now available via Mailman 3. So you can interface with it like a forum. Just, Google for OpenStack Discuss mailing list, subscribe, and go to the archives, and you can, reply to that, and you can read the post right there, just like it's a forum. It's pretty great. So again, thank you so much for listening to this video, coming to hear what I've got to say. It would do me a lot of good if you could like and subscribe to this channel. On this channel as well, I have a podcast, the Gross Out Podcast. Episode 1 is up right now, where I'm talking to Alex Scammon about what gross means, why we call it gross, and sort of the difficulties of running an open source policy office. So I'd love to hear you there. And please feel free to come out and join us in IRC or reach out in the comments if you have anything. I'm Jay Faulkner for G Research Open Source Software. Thanks for your time.